Welcome once again to Time Value of Money videos. I'd like to turn our attention now to advanced time value of money questions. And we'll start with question number 1. And it goes like this. You borrow $168,600 via a 30-year mortgage with an annual interest rate of 7.25%. On each of the first 18 monthly payment dates, you make your required mortgage payment amount and a principal reduction payment in the amount of $1,000. Immediately after you make your date 18 payments, what is the remaining principal balance of your mortgage? Okay, so this is the problem. We, again, just to go over it quick for you, we borrow $168,600, 30-year mortgage. The rate is 7.25%, and we make 18 payments of whatever the required payment is. We'll figure that out in a moment. And we also pay an additional $1,000 every time. And immediately after we make our date 18 payments, plural, what is the balance of the mortgage? Okay, so let's go down here. Here we go. So this problem is multi-step. So it's a great problem, by the way. Okay, step 1. We determine the payment size. And we've learned this before. The size of a payment is equal to the loan amount divided by the appropriate PVIFA. In this case, it's $168,600 divided by a PVIFA where the rate is the 7.25% annual divided by 12. And that gives us 0.00604, and sometimes I add the 1667. Anyhow, and N is 360, a 30-year mortgage with monthly payments. Okay, and so that's the formula. And then right here, I put in the numbers: 168.6 divided by the actual PVIFA formula. You can see that there, if that's familiar, and we get a familiar number, 1150.15. I mean, we've worked with this before. Okay, so that's step 1, kind of easy. Now, step 2, we find a future value of an annuity for the principal reduction payment annuity. That's the additional $1,000 payment we make at each date that we make a regular payment. Just so you're clear on that. Look here, what we've got going on here. This is the stream. So here at date 0, I get my 168.6, and then at date 1, we plan to pay 1150.15, and we're also going to make an additional payment, a principal reduction payment of $1,000, and the same for date 2, date 3, all the way up to date 18. And the idea here, what's different about this is we're making these payments every time we make a regular payment, up to date 18. And the question, of course, is, hey, what's my remaining principal balance at date 18 once I do all that? Well, in step 2 here, we're going to figure out the future value of just that $1,000 annuity, the principal reduction payment annuity, important term, principal reduction payment annuity. We're going to find the future value of that. Why the future value? Because when we find the future value of that, it will take into account all the benefits we got from paying the additional $1,000 at each payment date. And those benefits we will see shortly involve a reduction in the remaining principal balance owed after each payment, which would affect the amount of the following payment that goes toward interest expense. And because the amount that goes toward interest will decrease and the payment size is fixed, it means the amount going to reduce the principal will grow above what would have been without the $1,000 principal reduction payments, and therefore we get a nice benefit. Okay, so the future value of the annuity at date 18, the standard formula is future value of annuity is annuity cash flow times an FVIFA. In this case, the FVIFA has an R value of this, and then N of 18, because we're making 18 payments. And the annuity cash flow, of course, is 1,000, and the FVIFA looks like this: 1.00604 to the 18th power. That's 1 plus r to the n minus 1 over r, 0.00604. And when you do, and this value right here, by the way, is shown to be 18.9548. Notice that a future value interest factor for an annuity is a sum of future value interest factors. Each future value interest factor is greater than 1, except for one of them that's equal to 1, because of the way we built the FVIFA. But we're not surprised then that for an FVIFA, its value is bigger than its own n. The opposite of what was true for a PVIFA. So replay that and think about that. That's an important thing to know. Anyhow, 1,000 times this is, of course, $18,954.80. Notice that we paid a total of $18,000 extra dollars, but this benefit that I've calculated here is bigger than $18,000. It's $954.80 bigger. Okay, so that's an important thing to realize. Okay, and so now let's go and take into account step 3. Okay, so step 3 is calculating the remaining principal balance at date 18. So here we're going to do it. And so we're going to start off by doing this. And then we're going to adjust it for the 18,954. So at date 18, the remaining principal balance would be, as we've seen before, the 1150.15 times a PVIFA, accounting for the remaining payments. So the R, of course, is what it was, and N would be 342. 342 is just the 360 minus the 18. That gives us the 342. So what we're basically doing there is summing the value of all these payments here from date 19 to date 360. Right? Now, we're not going to have to make all these, but for now, we're just going to assume we do, and we'll get the remaining principal balance initially by just doing what we used to do. Take the payment amount and multiplying it by a PVIFA that reflects the number of remaining payments in the end value. This PVIFA is 144.4221. Excuse me. And when we multiply this by this, we get $166,107. But that's not a remaining principal balance, because that doesn't account for the $1,000 payments we've made along with each of our regular mortgage payments at dates 1 through 18. And we did the analysis on the adjustment. That's the 18,954. So here we will subtract the 18,954 from this, and we get our answer. 147,152. So the remaining principal balance at date 18 is $147,152 and some change. Okay, so that's the answer. But now I'd like to show you and allow you to get even more clarity on this, because this is an important thing to understand. So what I have here is I have a loan amortization schedule for this loan. Excuse me. In red, we see the case where if we had not made the additional payments. And you see here at date 0, we start off owing $168.6, and then at date 1, we make our first payment of $1150.15. The interest on $168.6, which would be $168,600 times 0.006041667, is $1,018.63. And therefore, since we paid $1150.15 and this went toward interest, the difference between this and this, which is $131.52, is the principal reduction. And then therefore, if we hadn't made anything but the regular payment of $1150.15, our remaining principal balance at date 1 after the payment will be $168,468. Okay, it's this minus this. However, we did make an additional payment of $1,000. And now we want to recognize that. So over here in blue is what we actually did. So at date 0, we had a principal balance of 168.6. That's how much we borrowed. And then we make our first payment at date 1. Notice it's the 1150.15 from over here plus 1,000. So it's 2150.15. And now the interest due on the first payment, of course, is the same, 1,018.63, the same as over here. And the principal reduction, of course, will be $1,000 higher than it was over here, 1131.52. And therefore, the remaining principal balance at date 1 is 167,468, which is $1,000 lower than it was over here, where we assumed we didn't make a principal reduction payment. Okay, but the benefits gets better. Now at day 2, I make my second 2150 payment, and since the balance was lower here, when I multiply that balance by 0.006041667, I get 1,011.79, which is smaller than the 1,017 over here, because this balance here is smaller than this balance here. It's very important that you see that and understand that. And this is where the benefit starts to kick in. We have less interest due, therefore, my principal reduction payment, instead of just being 1,000 more than this, 1132, ends up being 1138. And so the principal reduction is bigger, not just by the additional 1,000, but by a little bit more. And now we're down to a remaining principal balance of 166,330, which is more than $1,000 less. Excuse me, more than 2,000 less than 168,336, as you can see. So that's the benefit. Again, when we make the additional $1,000 payments in these payments, it reduces it increases the principal reduction amount, and therefore it reduces the balance, which then reduces the interest we owe next time relative to what we would have paid over here. Okay, in interest. And that benefit carries down. And so you can see that the remaining principal balance, if we had not made any payments, was 166,107, same as we saw up here. Right there, the one, okay? Now, it's off by a few pennies because in the spreadsheet here, even though it says 1150, it was really carrying a number with more places out than 0.15, and so we're off by a few pennies. But the answer is precise. It's just a rounding thing, and it's a non-issue. So 166,107 is the remaining principal balance at date 18 if we didn't make the payment, the extra $1,000 payment each time we made a regular payment. But over here in blue, we're showing, what really happened in this case when we really made those additional $1,000 payments, and therefore the remaining principal balance over here is $147,152, which of course is what we have up here. Again, I'm not worried about the difference in the pennies. I've explained that before. So that's a very important thing to know and to understand. So again, this sheet here is showing you loan amortization schedule, a loan amortization schedule. Sometimes it might be referred to as a loan amortization table, but it has the columns. Don't forget the columns: the date, the payment amount, the interest, the amount of the principal reduction, and the new balance. Okay, and this is an important thing to understand. Please spend time staring at this loan amortization schedule and make sure you understand it. Very important. That's all for this video. Thank you for watching.